Alright, let's talk about something that I grew up with. One of the first things I learned to fabricate with. Your OFW, your oxy-fuel gas welding. And oxy-fuel basically means you are using some type of fuel associated with this. This is also referred to as gas welding because it involves a combustion component. And basically takes oxygen and some type of fuel and combines them into a flame, which generates, of course, heat. And of course, the heat, as we know, is a part of the welding process. So, or for most welding processes. So as a result, we have O2 and some type of fuel. Now the most common fuel used with oxy-fuel, and you probably already know what that is acetylene. Now, just before we talk about acetylene, just realize that acetylene is available for us, but it's not actually the only fuel out there. It's just the most common for our particular accessibility and applications. And so economics plays a lot in the process of what materials you're using in terms like an oxy-fuel. So acetylene is available. Now I'll go ahead and spell it out for us, just in case. I wouldn't have been able to spell it if I didn't look it up in the book, to be honest with you. Alright, so acetylene and combined with oxygen creates the flame that we're used to seeing. You know, common terminology associated with this would be torching. You know, you got your oxygen tank and you've got your acetylene tank. Actually, I probably got them reversed here because we typically throw a lot more oxygen into the process. Each one of them has some regulators on them. And two little lines come out into our torch with some other regulators and valves on it. Not a regulator, but a valve to create the combination. Of course, we strike and then we get our flame. So pretty basic. Most everybody understands that in this particular field or has seen it. And if you haven't, never forget that you can just Google the process that you're interested in seeing live action, and you will probably find it right on YouTube. So that's the great thing about our access for technology now. We can see all sorts of things being done. Now this particular process obviously is using oxygen acetylene for the welding process, and it's great to watch. You can even find some great tutorials, and you can find step-by-step procedure if you wanted to watch it happen. But this was one of the first things that I learned growing up, was actually how to use the torch and do some cutting primarily, although we did do some brazing along the way as well. Now, one of the big uses we always used it on the farm was for bending things. You know, when things you couldn't get bolts off, or things just weren't where they needed to be, you always heated them up and bent them to actually get them to where you need them to be. Interesting little thing about oxy-fuel or oxyacetylene welding is it actually can achieve temperatures of 6,300 degrees Fahrenheit. That's hot. I really don't know what the practical heat temperatures are in our common torch applications, but that's amazingly hot if you were to throw the acetylene to it. So a typical oxyacetylene setup, you're going to have your oxygen tank, your acetylene tank, you've got your regulators. Of course, I already drew this out, but we'll do it again. Fire resistant barrier obviously is ideal for this because we don't want the flame to get to this tank right here. As we understand it, oxygen can explode very easily when flame is given. Notice the chains in terms of safety holding the tanks in place, the torch itself, and the valves associated with controlling the flow from one to the other. This point out, I've never used natural gas and propane gas, but apparently they can also be used with oxygen in the same process. But what's interesting is it does provide a great little guide here. Now this class doesn't really get into the techniques so much as but this is cool information. And you can notice a different flame type based on particular settings associated with your nozzles, and also settings you would do that. So, and this is one of those things that you're going to learn through practice and learn through actual application, but always some good graphics out there for you to take advantage of. So as I mentioned, you can always look up on the internet and find videos and tutorials for all these processes, but we'll run through some of the steps real quick. First of all, in the procedure, safety being first thing, Oxygen and acetylene regulators are adjusted to relieve all the pressure on the diaphragms of the regulators and open approximately 1/4 of a turn. Acetylene is. And open where the oxygen's opened all the way. I remember growing up on the farm, that's essentially our key thing. You know, you barely open the acetylene and you open up the oxygen all the way, and you get your working pressure off of that. Scrolling down a little bit. Needle valve in the torch is open approximately 1/4 of a turn, preparation for igniting the torch. Your striker, that handy little thing that looks kind of like this. We have an old school one there. My grandfather was a pipe welder, and we had a lot of old equipment from his days on it. So anyway, the striker in there, and you get your flame tip created. Then you use your adjustments on your needle valve at the base of the torch to kind of balance it out. So we've got a terminology here. Neutral flame is oxy-fuel flame with a balanced mixture of oxygen and fuel. It's used for most welding operations. Carbonizing oxy-fuel flame is when there's excessive fuel gas. And you can notice the difference when you look at the flame down at the base, really, in all honesty. Of course, video with this would be better as demonstration, but you'll be able to make the adjustments when you can see the levels, sort of the bluish nature of it. And you can tell the difference between, you know, excessive oxygen, too much oxygen, too little acetylene, and that kind of thing. Obviously, your neutral flame is what you're going for most welding applications. Now, as far as procedures go, once you get your flame balanced out, you're going to direct it at the parts. You're going to get a molten metal weld pool that is formed associated with whatever is being melted. You manipulate the torch back and forth to distribute the heat, or in our case, as you're bending things to distribute the heat. You'll learn to see a lot of little features about this process to let you know when things are ready, and you can add and fill the material by dripping it into place. Your welding torch and filament material are held at 45 degrees to weld the part, and your position depends on all your joint and all that good stuff. So the normal things that come through experience of doing it. So as far as equipment goes, pretty basic, pretty standard, and you know, a component of just about every fabrication out there is a acetylene torch system. So they come in handy to carry around sizes as well as the big tanks that we're used to seeing. Now, where do you use OFW? Well, a lot of times it's used in things like repair work. As I mentioned, you know, we use it on the farm all the time for repairing things and cutting. Although it does have some limits in terms of, I will say cutting on there. Although there's a lot of better ways to cut things if you're in a larger production operation. It does have some limits though. Cutting, my gosh, what the heck am I doing? There we go, cutting. Repair and cutting. And there are some limits though to the process in the fact that, you know, you can't just take a big slab of metal and be able to effectively work with a torch. You know, typically a 1/4 inch or less is what you're going to look for in terms of applications with torch. Doesn't mean we haven't gone thicker with it, but you know, this is sort of the thickness that we can work with fairly easily. Another big advantage of OFW is the fact that it's usually more portable than most welding operations. You know, for most arc welding, you have to bring in a generator if you're in a field or have access to high-end, or you know, a lot of electricity. Oxy-fuel basically means you get to roll up your 2 tanks and take care of it. So its portability is one of its major advantages and preferences. Now, if you have any experience, I didn't really mention in the last one part about it, but if you have any experience with torching, you understand that as you heat up your metal, if you're going to use it for cutting, as you're heating up your metal and you start to see that spark, then you apply the needle valve, you open it up to throw more oxygen to it, which is used to blow the molten metal through the point in question and create the cut. So not only is it using oxygen to help create the flame, the oxygen is actually part of the actual cutting process. Now, you wouldn't use that if you're actually using it for welding application, because then you would actually blow away all the objective of the molten metal. So the cutting is, you know, sort of a different application by hitting your lever there. All right, so that's a good stopping point there. There's oxy-fuel, and you know, probably a lot of you have some experience with that or seen it done. And if you haven't, go YouTube it, or any video search will probably bring up some great examples of how it's done. Anyway. Good stopping point. We'll see you next time.